start recording and let's go. So thanks everyone who was able to attend this webinar. This is a unique webinar for troubleshooting with WinDriver. My name is Daniel Bar. I'm the Technical Customer Success Manager at WinDriver. If you already experienced our product, we've probably communicated before. You can see my email on the screen, danielb@django.com. Feel free to contact me regarding any question or further question on this webinar or general information on WinDriver. So let's start. First, I want to invite you to our future webinars. We are having a few webinars each month. Some of them are introductions, some of them are dedicated for special subjects like this one for troubleshooting. I will post on the chat now an invitation for the next webinar tomorrow, Linux troubleshooting. We will have two introductions on September, and we will launch WinDriver new version on October with two major significant features. So I really recommend you to save the date. I also send now on chat the link to our LinkedIn page where we post much relevant content and future events. So I invite you to follow us on LinkedIn and stay updated, and to sign up to our newsletter, which we are not spamming. We only send relevant content and updates regarding future events. So these are the three links that I have added to the chat now. I really recommend following us and joining, so you can stay updated on the latest updates. On December, we will have, as I said, distribution webinar, and we will host two very unique, and I know that a lot of people asked for kernel plugin webinar and interrupt handling webinar, which will be a hands-on, which means we will demonstrate how to perform or the best practices to work with kernel plugins and interrupt handlers. So let's start and see what we have planned for today. So I can we have three parts mainly for this webinar. The first one is troubleshooting foundations. We will go over tools, methodologies, and the different development levels for starting troubleshooting. We will have a short WinDriver overview for the ones who are not familiar with WinDriver, or perhaps don't know, not too familiar with how it works. It is important for the troubleshooting to understand the mechanism and how it works. And in the end, we will have a few case studies, DMA related case studies, interrupt handler, device opening, and more regarding common issues when developing drivers, and specifically when working with WinDriver. So let's start and talk about the troubleshooting foundations. The first, I think, thing that you may think about when thinking about troubleshooting is the logs. We cannot investigate or troubleshoot or even start to understand where the problem is without getting a log, whether it's a pop-up from the application, the driver, or other sources. Now on Windows, we have several sources that Microsoft provides us with in order to find out what's the status or what the issue may realize. I will go over a few of them. I really recommend getting familiar with these tools. Read about them, maybe open them on your devices, and see what kind of information each one of them can provide. So when you troubleshoot your driver, you will better know where to go and where to look for the specific logs. And I do want to say that one of the main challenges for debugging troubleshooting drivers is to know where to look or find the root cause, because sometimes the fix is easy, but we are dealing with such a complicated environment with a lot of moving parts, the hardware, the firmware, the kernel version, the operating system. I mean, there are a lot of things that can get in our way, and getting familiar with the tools can help you identify the root cause more quickly and I mean faster, so you will be able to resolve the issue quite soon. So I will talk about the WD debug later on. This is WinDriver in-house tool for troubleshooting WinDriver or your driver. I will further discuss it later, but it is not a Windows tool, it is a WinDriver tool, and it provides a lot of insights. So if we have communicated before in support related issues, we've probably asked you for the WD debug log. It is very insightful. I will talk about it later. The second one is the PNP util enum devices. The PNP util have several functions. It can enum devices, but also the lead driver or load driver. It provides a list of all the plug and play devices along with their driver information. It helps identifying and manage devices and their associated drivers, aiding in troubleshooting and maintenance. So if you can't find your device, and I will talk about it later, on WinDriver or someplace else, you can't find the INF on the INF folder, you should look via the PNP util enum devices, class, or anything else, and understand how this command line work, so you can utilize it to see if Windows recognize this device. The second one is the Setup API devlog. It's a file generated by the Windows Setup API during the installation or configuration of hardware devices and drivers. It records detailed information about the device and driver installations, errors, and other related activities. It is valuable for diagnosing device installation failures, identifying driver conflicts, and understanding the sequence of events during device setup. This is a key log, in my opinion, if you are dealing with distribution driver, but not just that. If you ever talked about us with difficulties installing WinDriver or your distributed app or driver, we probably ask for the Setup API devlog. It is very informative. I really recommend opening it up, and it also indicates issue quite easily with 3 exclamation points. On the case studies, I will go over such log and show you how we see it. But this is one of my favorite logs because it provides a lot of insights pretty straightforwardly. The other tool, and it's a much, let's say, heavier tool, it's the WinDBG. It's a powerful debugger provided by Microsoft for analyzing and debugging Windows applications, driver, and the operating system itself. It helps developers identify and resolve software issues, crashes, and performance problems. WinDBG allows users to analyze crash dumps, memory dumps, and live debugging sessions, aiding in pinpointing the root causes of software crashes and behavior anomalies. If you ever encountered a crash issue and you reached us with it, we will probably ask for the WinDBG. Hang, crashes, anything that, anytime we need information about abnormal behavior of the operating system caused by kernel issues, we will ask for the WinDBG. It is a very elaborate, it has a lot of logs, and it's a very powerful tool. You can get a lot of information from it, you can run it, pause it, and see live the processes that are running in the background and their effect. So this is another tool I highly recommend getting familiar with. Another one is the event viewer, which is a utility that provides a centralized location for viewing and managing various systems, security, and application event logs. It allows users to monitor system activities, troubleshoot errors, and track changes on the system. It helps tracking system events and review error messages, facilitating efficient problem resolution and system monitoring. So it speaks for itself. You can see the events taking place in the operating system with specific with specific purposes. I mean, the filtering there is easy, and you can locate the event and track the occurrence. The other two are somewhat similar: the process monitor and the process explorer. So the process monitor captures and displays real-time information about system and application activity, including file system, registry, and process or thread activity. It's used for diagnosing issues related to processes. The Processes Explorer is sort of advanced task manager that provides detailed information about running processes, their dependencies, and system resources. So both of these tools are essential for troubleshooting application crashes, identifying resource bottlenecks, and understanding the behavior of running processes. So this is an initial list or basic list for troubleshooting driver, or see what's going on in the kernel, in the kernel mode, or the processes in the background. Save that list and get familiar with at least two of the tools here, because it can make things a lot more easier when troubleshooting drivers, especially with Windows and all the defenses it have and all the sophisticated mechanism that Windows specifically. Tomorrow we have a webinar on Linux. Windows specifically have a lot of mechanisms that are aimed to protect the user in the end, but it makes our life as driver developers much more difficult, because we need to be very cautious and very transparent about what we are doing and what access we should get in order to operate in the kernel mode of Windows. So in order to understand what's happening on the kernel level, as I said, we rely on logs, and each issue has its logs, and depending on the errors or phenomena. So that really depends on what error are you getting, and then you should know more or less where do you need to go, which kind of log you should look into. So in order to start solving the problem, we look at different parts of the computer, from the physical parts to the software, and narrow down the possible reasons for the issue. So as we can see here, we have hardware, we have the card, we have the kernel version, the operating system version, WinDriver version, perhaps the IDE version. There are a lot of moving parts when we develop driver, and we need to understand where the issue lies. So if you get a build issue, the first thought would be it's an IDE problem, but perhaps there is a problem with how the operating system is compatible with your IDE or something else. So we need to look at the greater picture and then start narrowing down the possibilities, and I will show you how we do it in the case studies. I'll show you how we do it here on WinDriver. So once we can see, once we have a clue regarding where the issue takes place and where we should look and investigate, we can get the log and start looking for errors. Now, not all the time we will understand from the log what the issue is. Sometimes the log will show that everything is okay. Sometimes it will show that show us an error we are not familiar with. So one way to troubleshoot is to follow the log and try to understand it. And if it's clear, that's great. But if it's not, we need to start thinking out of the box. So another way to troubleshoot is to have more than one example. for instance, a driver that works on Linux but does not work on Windows, or a device that stopped working after upgrading the kernel version. Okay, in these cases, it is best to diff and regress, which is this part. The second line, diff and regress the working and the non-working logs. Our favorite tool here at WinDriver is the Notepad++. Sometimes, and a lot of times, clients reach us and say, "Hi, it's working in WinDriver 14.5, but it doesn't work on WinDriver 16.0. Or again, it's working on Windows and not on Linux." So then we ask for the logs from both computers, or both devices, or both operating systems, and diff and regress them, the same logs. And it gives us a clue what went wrong at what point, how it looks in one place and how it looks in the other place. And then we are getting a better understanding of what went wrong at what phase. And as I said, we need to eliminate, because there are a lot of moving parts. We need to find what went wrong and start eliminate all the other options. And if we have different versions or different examples of one working and one non-working example, it will be much easier to eliminate other parts in the process. And I will show you it goes back to the hardware even sometimes. Let's say the interrupts were not enabled in the card itself. So after going through all the process of writing a code and compiling it, and suddenly the interrupt is not working, you have to go back to the hardware. So we really need to, the whole point of this page is to emphasize how complex our environment is and how we should really consider every part of it. So this is a pretty straightforward scheme for troubleshooting. So if it works, log it, and if it doesn't work, log it and diff and regress the both. This, I think, the best way or the best methodology for troubleshooting. It can be an operating system, it can be different cards, different PC or chassis, different WinDriver version, different kernel, different anything. If something went bad, ask yourself or find an example where it did work, and then you will be able to diff and regress both logs and get a better understanding of what went wrong. Another thing I think is important to note is that we're working on different levels, and when we develop drivers, as I said, we enable interrupts both on the code and eventually on the hardware. So on the hardware level, we have the interrupts, the memory ranges, the bandwidth, the bit stream, the header types, configuration space. On the kernel mode, we have the kernel version, the kernel debugging, the kernel logs. In the user mode, we are performing the reading and writing, the DMA, the interrupt handling. They are all connected. They are all related. So if you have a problem with the DMA, you may want to check it on the user mode, because we define the DMA operation in the user mode, but it takes place on the hardware. In the middle, we have the operating system that needs to, in case of Windows, it needs to approve it. The INF is supposed to be compatible and include the DMA option. So this is another thing to keep in mind, that the development is taking place on, let's say, different levels, but they are all connected. And sometimes it is hard to defer, to understand really where the issue relies. Now we will have a quick overview of WinDriver in order to, it will serve us in the next part in the case studies, so we can understand what went wrong when installing WinDriver. So if you are not familiar with WinDriver, WinDriver is an easy user mode driver development. You can automatically generate driver code in different languages. for example, C, .NET, Visual Basic, Python, and Java. We have a sample folder for each language, and you can develop drivers in different languages. We support any USB or PCIe device, regardless of manufacturer, and we also have enhanced support for specific chipsets from Altera, Xilinx, and Lattice. The scheme is very simple. You can generate code. You need to modify it as per your device. You build it. Also using CMake, which is a great feature we have in order to easily build in across platforms, run your code and distribute it. So it saves a lot of time and effort during the driver development process in both Windows and Linux. How it works, what is the mechanism? So everything is taking place on the user mode, the development and the troubleshooting, the debugging, it all takes place in the user mode. So the app is written in the user mode. It contains an API, okay, WinDriver API, a lot similar to Win32 API, and it is calling a low-level kernel mode functions. So we know that in Windows, Windows requires INF. I will talk about it soon. It requires INFs in order to provide access to the kernel mode. So each WinDriver itself and each app generated via WinDriver has essentially two INFs: a driver INF and the device INF. The driver INFs allow the WinDriver API to communicate from the user mode to the kernel mode, and the device INF allows the communication between the WinDriver kernel module or the kernel module of your driver to your hardware. So if you install WinDriver or distribute your WinDriver generated app, you should know that there's supposed to be two INFs in order for it to function properly. So Windows will allow the communication from the user mode to your kernel mode and hardware. Let's talk for a second about two defenses Microsoft added to Windows in order to protect their users. The first one is secure boot. So secure boot is a security feature in modern systems that ensure only trusted and digitally signed software can run during boot. It verifies the digital signature of bootloader and kernel components, enhancing system integrity and preventing attacks. Since we develop drivers, we want Windows or the boot sequence to trust us. And in order to do that, we need signatures and we need verification. The digital signature is also this kind of protection. It's a cryptographic technique that confirms that the driver package comes from a legitimate source. It is helping to prevent unauthorized or tampered driver installation. So these two, let's say, mechanisms are asking for verification from the driver developer. We at WinDriver offer digital signature services. Now, up until last week or the last few weeks, the services, our digital signing services, provided a verification for the digital signature enforcement only. Okay, which means that the secure boot, you could have issues with the secure boot if your driver was not approved by Microsoft. What we added, and Windows changed its policy, changed their policy, and now they require that all the driver that will be installed on Windows will include an attestation signature, which also verifies through the secure boot. Okay, so our digital signature process is now including an attestation signature from Microsoft Partner Center. So your driver will be eligible or compatible through Secure Boot and the digital signature enforcement. So in essence, attestation signing enhances the Secure Boot processes by providing a higher level of assurance regarding the legitimacy of the signed driver. During the Secure Boot process, the system can access this attestation certification to verify not only the driver's digital signature, but also its signing context. So if you will ask for a digital signature today from us, you will have both signature. As you can see here, this is the old signature provided by us from Django, and the new one that includes two signatures. Now I will talk about three WinDriver very important utilities. They are unique to WinDriver, and they too can help us a lot during the troubleshooting process. The first one is the WD debug. This is a GUI application that helps monitoring WinDriver and your driver. What we can see here is actually the log of the WD debug when running WinDriver. So you can see the sequence, you can see what it does, the function it uses, the successful operation are marked in green, and the false one or the bad one are marked in red, so you can easily see where things went south. Another thing that makes it a lot more easier, and it is from the latest version, it got a new face, a much nicer and user-friendly face, is the clickable functions that takes you to WinDriver's documentation for this specific function. So if you get a red flag on a specific function, or you don't understand what it does, you can click on it and see a detailed description from our documentation. Every time, I guess, almost every ticket that is being opened on our support center, we ask for the WD debug because it provides really all the information we need. As you can see here, you can choose the sections to be monitored. You can choose the level. We always recommend trace. And the best part is that it sends the debug message to the operating system kernel debugger. So it doesn't have to be a separate log. You can simply send it to your operating system kernel debugger and see the full picture, and you will see WinDriver or the WD debug prints there and get a complete picture, a full picture of the occurrence on the kernel level of your operating system. We have a video on YouTube regarding this debugger, and you can find more information on our support center. One thing that is important, you can change the driver name to your generated driver. Please note that the kernel module have to be enabled. It has to be installed and enabled of your driver in order for the debugger to monitor your driver's operation. So how can you do that? How can you load your kernel module on Windows? This is why we have the WDREG, another tool that comes free with WinDriver. It's a dynamically loading and unloading your driver, replaces slower manual process using Windows Device Manager. Okay, so that's again WDREG frontend. It's a GUI app. You can install driver, uninstall them, start them, stop them, create registry entry. We have the GUI and we have the non-GUI, the command line product. If your device does not show up on the device manager, or you have the INF and you are unsure on how to install it, you can use the WDREG tool, and it makes everything much simpler in terms of loading and unloading drivers. It's both of the tools, the WD debug and the WD reg, are on WinDriver folder util. You can find it there and explore it. I'm sure you will find them beneficial. The third one is also on the util folder, but not just. The PCI diag and USB diag are two working apps, okay? And how come these are utilities? So once we have a working app, okay, both of them are showing or demonstrating complete interrupt handle source code, okay, that uses WinDriver functions, but it is working. So if you have issues accessing your device through WinDriver or through your generated app, you can open the PCI diag or USB diag, depends on your device, and see what happens. Now, if you open your device, you are able to access it using the PCI diag. There is probably an issue with, let's say, WinDriver or with your generated code because it was able to access it. But if you are unable to access it using the PCI diag, then perhaps it is an issue with the operating system or the card itself. This can be like a breaking point from if it's not working, then you need to follow back on your operating system, your card, your hardware, your firmware. And if it does working, then something is not right with the code, the app, or whatever. You need to figure out why. Because this is a working sample. It worked before, and it's supposed to work also now. So again, depends on your device, a USB diag and PSP diag, a PCI diag. You can open it on your from the util folder and also from the sample folder. Because it is a working sample of a complete interrupt handle source, you can use it for inspiration purposes and see if it is working, then how. You can see the code itself, copy parts of it, make modifications, and as I said, getting inspired from this particular example. The last slide for this part is regarding development steps and common issues that we see. So there are several development steps when utilizing WinDriver, INF issue, previous version interferences. Regarding INFs, we see a lot of times that when someone installs, let's say WinDriver latest version, on a computer that have or had previous WinDriver version, it causes interferences. So we recommend deleting previous WinDriver version and trace it from computers that are installed, that you are installing WinDriver latest version on. Missing DLL, the first case study will be about that. And architecture incompatibility, 32 and 64. That's more of a compilation, but let's say downloading 32-bit on 64-bit, or downloading ARM for Linux or something like that. Java wizard operation, when it's not recognizing devices, memory range issues, and license issues. I know that people are getting it is hard to understand maybe our license mechanism. We have it on our documentation. We have an elaborated guide that I wrote. You can ask me for it and I will send it to you. Compilation issue when removing the include and headers, missing IDE extensions, and 32 and 64 compilation, which require the special preprocessor definition. The thing with removing the include and headers is sometimes when users develop a driver with WinDriver and it works, and then they upgrade their version, they are not tending to generate the code from the new version. And sometimes pieces of the code, essential pieces of the code, are getting lost. So it is really important that if you are generating a driver with WinDriver, keep doing so with other versions. Otherwise, you may miss essential parts, as I said, and it will not work for you. And you will find it during the compilation. The user application can also have issued digital signature. If your driver or freshly developed driver is not digitally signed, Windows will not let you install and run it. Invalid handle crashings, DMA limitation, and interrupt handling, all of them are common cases when using the user application. And when talking about distribution, which we will have a special webinar for, the rename driver can sometimes have several parts that need special attention. You can follow the relevant page or the relevant section on our documentation regarding how to distribute your driver, and if you follow the steps, you should be okay. But again, last word about it, we can see how complicated it is relatively. Even WinDriver, it's an easy to use product, but it requires installation, the app itself, and then you compile the code, and each one of these steps has its own perks. So be mindful, just a kind reminder for us to be mindful during the whole process, so we can stop where we need and track the issues that pops up, investigate them. So we'll go over a few case studies. The first one is WinDriver installation, unable to initialize WDC, a very common issue. Driver wizard operation for unrecognized device on the wizard. We will talk about interrupt enablement issue. We had an interesting case, Linux device opening issue, which is interesting because it's a comparison between the two operating systems, one on Linux, one on Windows. We will see how we solved it. Hint, diff and regress, as we talked. Windows DMA issue, which is also interesting if you develop driver on Windows, and Windows version upgrade notes. Let's start. So if you installed WinDriver, you probably worked with it. You've probably seen the unable to initialize WDC. What it means essentially is that it can't find the kernel module. Okay, there was an issue with, as we said, the kernel module access goes via the INF. So there are instructions that says make sure that the WinDriver kernel module installed and enabled. Okay, this is the first thing. And then to make sure that high-end level API, WD API is installed in your system directory. Because it is common, the instructions are already on the error message. What I usually ask for is the WD debug log. As I said, the kernel module is related to the INF. We are unable to access the kernel module, hence the INF was probably not installed properly. What I love about the setup API devlog is that it brings you the message straight into your face. You can see the 3 exclamation points. It says, I have an issue here. You can see what INF you tried to install and what went wrong along the way. So this is a pretty straightforward example for the setup API devlog and how to use it. What we usually find is that there is a collision between the INFs, between the versions. So our suggestion is to remove previous WinDriver versions. It's something that I haven't said and I should have said before is that I recommend, we ask for logs because this is how we investigate. I recommend you to open the logs as well. Even if you won't understand something from it, you will be able to see what information you can get from it and how it presents issues, what it shows essentially. Even if you will not solve the issue yourself and you still send us the log, it is a good thing to be familiar with what this log is, what it says, how it says it, and so on. And then send us the log and we will further investigate. But I recommend getting into the process as well, even only for learning purposes. So as I said, we have the wdirect tool to remove, to load and unload kernel module. You can do that also with PNP util. Enum devices will show you the devices that are connected, and you can search for a specific class, in this case Django, because this is the class of WinDriver kernel module. And you can also delete drivers using the PNP util. A great tool. I recommend learning about it. Then we have to reinstall WinDriver after we cleaned the system, and make sure that the WinDriver driver is enabled on the device manager, which means the system gets it, recognizes it, it is installed, and everything works okay. Afterward, things should work smoothly. If not, go back to the logs. Another case would be the unrecognized devices on WinDriver. So when you open WinDriver, as you probably saw, you can see a list of your connected devices. This section is going to be upgraded as well in the next WinDriver version. It is worth waiting. So let's say you open the WinDriver and you look for your device there and you can't find it. Okay, it is unrecognized by WinDriver. What we recommend doing is opening the PNP util and enum devices. So basically, the PNP util shows what the operating system sees, what Windows sees. If it is not there, then Windows does not recognize the device. Perhaps there is an issue with the slot, or maybe with the card connection. Anyhow, you can isolate, you can eliminate and isolate the problem, and understand that the issue relies between your hardware and Windows, and you need to understand why. If it is there, you can see your device in the PNP util and on devices, and you can't see on WinDriver, on the driver wizard, then check with the PCI or USB diag tool, which we talked about, how to do so. You can look for it in the PCI or USB diag, and if it is there, then something is wrong with WinDriver. And if it is not, then again, you can eliminate and isolate the problem between the PCI diag operation and Windows. Contact us anyway if you are getting this sort of issue, and we will walk through it together. But this is just an example for how to think, how to look at the great picture and start eliminating the root cause. You can, of course, log with the WDebug GUI, which will give us a look about what's going on in the backstage of WinDriver. Why is it failing to recognize the device? Again, or the PCI or USB diag. It can monitor the operation and give us a hint. And the event viewer, look for hardware events and see again Windows tool to see what went wrong along the way. Okay, now we're getting to the interesting cases where real cases we got on our support center. So the client here uses a PCIe device on an FPGA with several interrupt sources. Okay, he said that there are no interrupts log in the log. He enabled the interrupts. This was the issue. He enabled the interrupts, but he can't see the interrupts log in the log. Where do we start? So we know that there is a device and it has a firmware loaded and the interrupts are enabled on the device. We also know that he needs to define registries, generate interrupts, and listen to them. And he says that there is an issue. He starts listening to the interrupts, but he doesn't get logs. What we've asked from him is the WDebug log. And when we opened the log, we saw, again, pretty straightforward, an error in transfer commands. The memory address is out of range. Okay, due to malformed transfer commands, the interrupt was not enabled. So the problem was not in the logs not showing. The problem was with the interrupt enabling. Malformed transfer commands prevented the interrupt enablement, and the interrupts were never enabled in the first place. Therefore, the client didn't see the logs. But the WD debug log pointed it out pretty fast. This case is the one with the Linux involved. Again, very interesting. So the project runs on both Linux and Windows. This was the client description. The Windows device and driver runs with no issue. Okay, so there is a device, there is the firmware. We have the Windows version. The device opened via Windows, and they've managed to run it smoothly. But when running on Linux, they weren't able to open the device. So there was an issue with Linux. This is what we thought initially, because it worked on Windows. We have asked for the dmessage, the Linux kernel debugger, in order to see what happens on Linux, because we understood that the issue was with Linux, and we see that Linux printed can't change power state, the configuration space is inaccessible. It didn't say too much to us back then, because we are not troubleshooting Linux, we're troubleshooting WinDriver. We didn't understand at first place how it affects WinDriver operation. So what we asked is the WDebug log, WinDriver debugging tool from both Windows and Linux. So we took the one from Linux and the one from Windows, and diff and regress them as we saw. And what popped up for us is, first of all, the errors. The log from Linux was filled with errors, unknown PCI header type, and then it related to us to the previous error with the configuration space. Since the header types are sitting in a configuration space, and Linux screamed the configuration space is inaccessible, we started to understand that perhaps something is not working well with the device, and not necessarily with WinDriver operation. The question is why it worked on Linux. If the problem is with the device, then how come it worked with Windows? We saw that we have an issue with Windows as well. The translation bus address failed, and it returned an untranslated address. So there was an issue with Windows as well, but due to a fallback, the operation was not stopped. The device kept functioning. So what we understand now is that the header types were unknown, and both Linux, therefore Linux and WinDriver could not access the configuration space. So the problem was not on Linux, it was on the firmware. Okay, the configuration space wasn't set right. It's a fortune that we found it at this stage, because if this was distributed on Windows later on, it may have caused issues on the distribution side, on the client side. So this is a very interesting case of two operating systems that, using the diff and regress, we found not only the problem on Linux, but also a problem on Windows, which was presumably working well and preventing future issues and probably a lot of headache. This case is talking about Windows DMA sample, a new Dell workstation interfacing with Xilinx device. The operating system is Windows 11. Windows crash after installing the INF. So this is interesting because no DMA transfer was actually made, only when installing the INF. On installing the INF caused the operating system to crash. So now this is a scheme. We wanted to eliminate what causes the issue. Is it WinDriver? Is it the INF? Is it the OS? Is it the PC compatibility? What went wrong along the way? Because something very significant needs to happen in order for the system to crash when taking place in the kernel mode. So we wanted to better understand what happened. So we asked for the mini dump for the WinDBG, and we look at the tray stack, which is the last operations took place before the crash. And we see it doesn't mention WinDriver. It gives us a lot of, let's say, addresses and hexa hints, but no WinDriver function or operation is mentioned. So we tend to think this is not related to WinDriver. However, the miniDAP does indicate that there is a PNP detection fatal error. Okay, and it says plug and play encountered a severe error, either as a result of the problem in the driver or the problem in the PNP itself. So we further investigate and we took this to Google, our dear friend, and we found out that Microsoft has a policy, a DMA guard, that prevents actually from INFs to be installed and perform DMA. Now, as I said, the INF should include DMA function. If you are using DMA, it needs to confirm the DMA with the operating system. Since the kernel DMA protection was on, Windows shut down as soon as the INF tried to even install himself and with the DMA functionality in order again to protect the customer, protect the client, the Windows user. So we saw that there was no issue with WinDriver and even not with the INF. On the opposite, the INF included all the information it needed. We had an issue with the operating system that the kernel DMA protection was on. So this is another important lesson, to be familiar with the operating system restrictions and the policies, so they will allow you to do whatever you want to do on your target computer. The last use case is running a WinDriver version upgrade. This is not exactly a use case, but it is important to understand. As I said, when upgrading WinDriver version, several changes or steps need to take place. We have everything documented on chapter 3.3 on WinDriver documentation. We recommend removing previous installations, make sure that the relevant INFs are loaded, updated the licenses. Each WinDriver license is bound to a version as well, registration code, VPID, and also the version. If you're using WinDriver 15.1, it won't work on 16, even not on 15.3. You need to update the license as well. It doesn't, we don't charge for upgrading a version, a license for a new version, but make sure it happens, especially when distributing. And of course, generate the code with the new version generated code, because as I said, a lot of includes, a lot of dependencies are updated there, so don't miss it. Troubleshoot with different regrets between versions if things are going wrong, and you will have a clue of what exactly wasn't working. And this is the last use case. I want to thank you everyone for joining, for listening. This is my email and our sales email. You can send questions on chat. I will look for it now. And you can send me emails regarding anything, regarding this webinar, regarding further questions, or further troubleshooting of your current drivers in progress. And thank you again, and have a great day or evening wherever you are.